So hello guys, welcome back to another problem of controls. So today we're going to go over this problem. So figure 3 on the left says that the ends of a bar slide along a wall and floor, and on the right there's a free body diagram of the bar. So we only consider states in which 0 degrees is less than theta is less than 90 degrees. So assume the endpoints of the bar remain in contact with the surfaces and the mass center G is at the midpoint of the bar. Use this figure for problem 5. So for the system and corresponding free body diagram provided in figure 3, find an expression for the normal force NA. So basically this problem is a force balance equation. So since this bar is resting in contact with both the vertical and horizontal surfaces of the wall as it slides, Um, and there's no vertical, uh, like it's not, yes. So since this bar is always in contact, we're going to sum the forces. And basically, the sum of the forces is going to be what? Let's think about it for a second. So in this case, the sum of the forces in the y direction and x direction are not going to be 0 because there's going to be a net force in the y direction since there is an acceleration upwards, but we don't know what the acceleration is. We don't know whether it is 0 or whether it is just a force. But our goal is to come up with a general equation for for the normal force at A. So how we do that is that we sum the forces in the y direction, and the sum of the forces should be equal to the motion in the y direction, which is going to be yg. That's going to be the displacement in the y direction. And acceleration will be if we differentiate the motion 2 times, which is going to be y dot dot g. And then Newton's second law basically says F equals ma. So basically, this is of the form ma, where a is the acceleration. And we don't know whether acceleration is 0 or not. So we're just going to keep it as the double derivative of this displacement. And this is equal to mg, which is the weight of the rod down, and uh it's going to be negative because we can define the positive and negative coordinates as x and y over here. So it's going to be equal to negative mg and then plus fb. So plus fb and then plus na. So basically, na is equal to mg um mg oh wait, yes, and don't forget that this is actually all equal to my dot dot g just over here. So mg, okay, plus myg double dot and minus fb is going to be equal to na. So we proved that this is the correct answer. Yeah, so that's the end of this problem. It's a pretty simple problem, but see you next time. I hope this video was helpful.